Hello everyone, my name is Seon Park and today I will talk about quantum devices. So let's start with the word quantum. So have you heard of the word quantum? Then what does the word quantum mean? When we think of the word quantum, we would think the tiny scale of things, and it is also true. But according to the Oxford Dictionary, the word quantum refers to a very small quantity of electromagnetic energy. Quantum has been used or studied from the 20th century, and it allowed scientists to describe the interaction between energy and the matter down through the subatomic realm. Until now, I explained about the quantum. Then what does quantum technology mean? Maybe it sounds obvious, and it refers to the technology that uses quantum mechanics. It is already near us, and it will be part of our lives. Quantum technologies are applied to various areas such as sensors, computing, and semiconductor. It will lead us to more powerful computing, more secure communications, reliable navigations, and etc. Likewise, it can be applied to various areas. I already talked about several areas that can use quantum technology. But more specifically, I would like to talk about quantum tunneling field effect transistor and quantum Hall device. It might sound weird or unfamiliar to you. However, these are not new devices, but it applied quantum technologies to the original device. So from now on, I would like to explain how do they work, what are the purpose, and what are some advantages and disadvantages of them. So let's start with tunneling field effect transistor. So MOSFET is a common device and might be familiar to many of us. Many people try to find an alternative or a device with a better ability. So therefore there are various studies undergoes, and one of the device that is alternative of MOSFET is tunneling field effect transistor or TFET. It is not a perfect device yet, but it uses quantum technology, which is tunneling. Then how does TFET works? Before explaining how TFET functions, transistor is composed of source, gate, and drain. For MOSFET, it controls the voltage to switch to flow the current. In MOSFET, source and drain are N-type, but the body is P-type. However, in TFET, source and drain are reversely doped, so the source of TFET is P-type and drain terminal is N-type. Also, the body is intrinsic, which means it is lightly doped. So the structure of TFET is PIN diode, and by applying gate bias, it is able to operate. By gate bias, electrons build up at intrinsic area, and when the conduction band of intrinsic region is aligned with the valence band of p region, band-to-band tunneling occurs. As electrons in p region flow to the conduction band of intrinsic region through the tunneling, the current flows to the device. However, when the gate terminal bias gets reduced, then the bands would not be aligned and current would not flow. So simply, it uses tunneling effect to flow current to the device. Until now, I talked about how does it function, but let's look at some advantages and disadvantages. First, it can use less energy to operate. And second, it has good ability to reduce off current. So the on-off ratio is relatively high, and higher the ratio, it means it is a better device or it has better ability. On the other hand, during the manufacturing process, trap can be formed. This trap is a space where carriers such as electron or hole can be exist, and with trap, tunneling effect occur more with less electron. Maybe it sounds advantage for the TFET, However, it is an advantage only for on-state, but for off-state it has negative effect. Likewise, there are advantage and disadvantage. Like tunneling mechanism is used in a device, quantum Hall effect is another mechanism that is studied for future technology. First, we have to understand quantum Hall effect. Quantum Hall effect was discovered by Claus in 1980. Quantum system at low temperature and high magnetic fields shows well-defined constant values for wide magnetic field or charge carrier density variation, or when a magnetic field is applied vertically to a two-dimensional electromagnetic object, the resistance in the direction of the electric field is zero, and Hall resistance in the lateral direction is quantized by h over e squared. There are already various sensors use Hall effect. When Hall effect sensors detect there are in a magnetic field, they perceive their position. Quantum Hall effect is also predicted as it can be used in a various area, not only for sensors, but also it can be used as transporting wires. Without energy dissipation, electrons can be transported, so it would be able to use less energy than before. Like this, I had looked at two devices that use quantum technologies, and these are the references that I looked up. And thank you for listening my presentation.